easy ones. Electricity is
A flow of electrons to a circuit.
passive. A circuit is
A complete path of electrons.
for electrons to,
Flow.
yeah, don't help her. Pass it. Electrons come from atoms. Give me 2 ways to get them to flow.
A battery,
Okay,
and then static electricity if you give it a path.
good. You got that same question last time, didn't you?
Yeah.
Yeah, I remember that. Okay, let's see here. Magnetism is the property of blank or blank between blank or blank. Magnets are either
Kissing.
I don't know, it's not an answer. Take a guess. Magnets are what do magnets do? Or repel, and they attract or repel because of blank or blank.
Dude, wet. Come on.
What do you know that magnets have? Every magnet has.
North and south poles.
So if they're north and north, it will
Repel.
repel. Okay, pass it
Yeah,
on.
west.
The definition,
Does that count?
the definition you should all have at this point, Sky. Well, I hope that wasn't doing what I thought you were doing back there. Magnetism is the property of matter where there's an attraction or repulsion between like or unlike poles. You should all know that now. Okay, who's got it? Jeff? What are the 3 kinds of materials that can become magnetic?
Cobalt, nickel, and iron.
Iron. Hopefully what you brought in today as a sport has one of those materials in it. If it does, pass it off. Okay, those 3 materials aren't always magnetic, but they have the ability to become magnets. They have the ability to become magnets because they have what kind of electrons? What kind of electrons? What? Ah, pass it off.
I should have did it.
Actually, when you get it wrong, you send it up here and we do the rest with the class as a whole. So, what kind of electrons?
Unpaired.
Unpaired electrons. The unpaired electrons don't guarantee that it's magnetic. It just makes, just makes each individual atom like a magnet. But if those atoms aren't all lined up in the same direction, forming little blank blank magnetic domains, then we don't get magnetism. Once we get them to line up facing the same way, we make magnetic domains. All right, who can tell me how they are related? Electricity and magnetism, what do they have in common? Zach?
They both have electrons.
That's true. And who said that? Who proved that first? Electricity can make magnetism.
Oh, that one teacher.
Yeah, what's his name?
Oh.
Oersted, good. Hans Oersted was the first to say that. All right, let's see if we can get to the next chunk here. Voltage, current, and resistance all describe what's happening to the flow of electrons. If we have a lot of pressure, a lot of force, that would be like a lot of voltage. If we get a lot of electrons passing us every second, that would be like a lot of current. Or amps, you're right. And if we add resistance, what happens to that flow? Slows it down. 3 ways to increase the resistance of a wire.
Increase it, make it bigger, or like,
We want more resistance.
make it smaller,
Smaller,
thinner, change the material of it. and
Yeah,
then-
to something that's got more resistance in it. Okay, what are you doing? That was fascinating. It looked like you were fixing a watch or something. You're just trying to poke a hole in your water bottle cap, huh? Moving on. So we know if we change one, we're going to change the other. We add resistance and it decreases the current. That rule that says how one affects the other is called Ohm's law. Okay, and a battery works through a blank blank between 2 and 1. These are the basic questions you all should know now, okay? All right, what we're going to do today is make our electromagnet. You were all asked to bring in a core. Get that out now, okay? Hopefully you all remembered. You're going to make an electromagnet, and then you're going to have a little time at the end of the period to practice with it. Everyone will practice with the electromagnet so that tomorrow when we have our contest, our actual fishing contest, you'll be skilled. And that's all we're doing tomorrow. And then we're going to get into more of this electromagnetism business. Can I have you talk while I'm talking? Thank you. All right, hold up your cord. Let me see what you brought in. Got lots of, we got big old carriage bolt here, we got some rods, we got some flat metal, some from a cabinet or something, bolts. Okay, we're all over the map. So let me just take these three as an example. Okay? What's going to happen, guys? See, I knew better. I knew that if I said you must bring in a core on Monday or Tuesday, that half of you would probably forget. Looks like more than half remembered, so that's good. But we only need one for your entire station. So at each station, you're going to the same stations you were at on Friday. If you were gone Friday, excuse me, if you were gone Friday, you need to ask and I'll put you in the station. But you're going to go to your station and you're going to look at what cores were brought in. Hopefully you have at least one. And you're going to choose from those which one you think is the best. And there's a lot of factors, even more than what we talked about, so it's kind of difficult because one of the factors is we're going to be doing this fishing contest and it involves navigating around some obstacles. And if your core is too big, that's going to be a problem. This otherwise might have been a good choice, but this long part here and the hook is going to be problematic. I'm just telling you that. So probably wouldn't want to use that one. If it's the only one you got, then you ought to use it, okay? Then you're down to these two nails. Given the choice, which one would you choose? I would go with the bigger one. This is still a little bit too big for me and might be a little more difficult. But the only reason I'm going to go with the bigger one, the diameter is very similar. The bigger one will give me a little more wiggle room so I can wrap this tightly with the wire. And I remember that I'm going to have to leave some of that exposed. So is that a little nail? What was yours? I'm going to use this one as an example for right now. You're going to need to leave some of it exposed. You can see these are some that were done in the past and how the end here and the end here are exposed because the wire itself is made of copper. Will copper become magnetic? No. It will create magnetism around it which we'll use to magnetize the core. So this needs to have iron, nickel, or cobalt in it and you need to leave some of the end exposed so that things can stick to it. Today you're going to be picking up washers. Tomorrow it will be something else, okay? But if you can pick up more than, oh, I don't know, 16, that was the maximum that's been held so far, you've got a pretty good coil, 16 washers, okay? All right, so I'm going to walk you through how to wind the coil. I've given you step-by-step directions at your station should you get stuck, but it's a lot to absorb, and there's some other details I want to go over, okay? In addition to winding the coil, you're going to have your rod here, which I have made myself and paid for out of my own pocket, so I would expect you're going to treat these with great care. You're going to be wiring up the rod, your fishing rod, so it's ready to use, and I'll explain that here in a little bit. So it starts with your magnet wire. First thing you got to do is take off the tape. My recommendation, don't use the scissors. You're going to peel it off, okay? Oh, let me back up. I went a little bit too far. First step at your station is to determine if this is already magnetic. The rules say it can't already be magnetic. So put your compass on the table. Once you've selected the core you think you want to go with, bring it up close to the compass. If it makes the compass move more than a quarter turn, which this one does, it's already magnetized. So what you're going to do is get rid of the magnetism. We talked about two ways of doing that. What are they?
Vibrate it, or you give it a path?
No, it's not that there's electrons flowing through it. You vibrate or heat. Those are the two ways. You use them both, it's even better. What we'll do, I'll have the door propped open there. You'll take the hammer next to the door, you'll take it out there on the concrete, and you'll bang on it, okay? Point it so it's facing east-west, not north-south. We don't want to magnetize it to the Earth's magnetism. So hit it in random directions, bring it back in and try it again until you can kill most of that magnetism. I don't mind if it turns some, but if it turns a quarter turn on the compass, that's too much, okay? Kill the magnetism. You also need to make sure that it can be made into a magnet, that it has iron, nickel, or cobalt. So if you're not sure, bring it up to me and we'll test it. If it sticks to the magnet, you know it can be made into a magnet. Okay? So you've selected your core. That's step number 1. Step number 2, you get your wire ready to go, the magnet wire. It's all been wound up in a nice little roll here for you. You just have to take off the tape. You want to have your partner, someone at your station, helping you with this. There's 1 or 2 other people. They can work on getting the rod prepared, and I'll tell you more about that in a second. So I need someone up here to be my partner right now. Okay, Matt, come on up. And this is part a lot of people screw up. They just kind of let go and it just turns into this tangled mess. At this point, you find the wire, find the end, and you start to carefully unwind it. It is 10 meters long. So if you're not careful, you'll have a terrible mess. He's going to walk towards the back of the room, down one of the aisles. I want you all, just go slow, just slow down, slow down. I want you all to go this direction. Don't anyone go this way because then we'll end up getting our wires crossed and tangled. It's worth taking the time to unwind this slowly and carefully so that you don't get it tangled. If you try to do this too fast, you'll get terrible knots and then you'll just be here all day untangled. Okay? Now, once he gets it pulled out to the other end, I want him to let go. I don't want him to hang on, so go ahead and let go. And you guys will forget one of these things, I'm sure. The reason I want him to let go is because when I wind this around my core, every time I do this, the wire wants to do this. If he's hanging on to the end, it's just going to keep curling up, curling up, and curling up until it's all full of knots and it's just a mess. So he lets that end go free. You're going to have another job here in a second, but stay put right now, okay? Then you get out your meter stick, and we're going to measure in inches for this. I want you to measure 30 inches from the end. Okay, this much. That's how much you want to leave straight on the end that you start your winding with. When you begin winding around your core, remember to leave some exposed, like ½ an inch on each end. So I'm going to start winding and wrapping around the nail. Now if it is a nail or smooth like that, you can wrap real quick like this and then push the turns together. Push and pull. Push the turns together and pull the wire so it's nice and tight. The idea when you're winding a coil, normally a machine would do this for you, a motor, is you want each turn to be straight up and down as much as possible and parallel to the next. You don't want to do a lot of crisscrossing. Every time you crisscross, the magnetism isn't going to help out the magnetism of the next turn. Does that make sense? It's like when I wanted my coil to be better, it's like stacking magnets one on top of the other. Well, each turn is doing the same thing. It's getting them to be all parallel to one another. Now, you can get carried away with this. You can spend so much time trying to make a perfect coil that it'll take you 15 minutes to wind up 5 feet. You can't do that. You got to go fairly quickly. You should be able to get this wound up in about 10 to 15 minutes. Okay? And what will happen is I'll work my way down towards this end of the nail, and I'll leave another ½ inch exposed on that end. Because remember, it's the exposed part that we're going to use to actually pick up washers. The part covered in wire, nothing will stick to it. When you reach the end down here, then you keep going in the same direction, but now you start heading back. You do your second layer. When you reach this end, you head back the other way. You do your third layer. And every time you get another layer on top, it gets easier and easier because it gets thicker and thicker. Wind it tight, wind it straight up and down, and parallel. Everybody got that? Head up again. Finally, when you reach the end, you're going to leave how much straight? 30 inches, just like I did here. Now what Matt's going to have to do periodically, come up here. I'll do what you'll do. You'll just hold this like you're me. And you've been winding away. And you can see that as I do this, you see what's happening to the wire there? How it's getting all curled up like that? Okay, so he's holding that and he's winding away. What I'm going to do is come up and just regularly do this. I'm going to grab the wire and I'm going to run my hand along it. Grab, run my hand along it, okay? Because what I'm doing is I'm helping get rid of all the curled up part to keep it from getting all tangled up. If you don't do this part, you're going to end up with all sorts of knots. And he keeps working, and then I'll come back and do that again in a little bit. Okay? All right, so now we've reached the end. We've got 30 inches here and 30 inches on the other end. Okay, so just pretend that I finished and I have 30 hanging off. At this point, what you should do is take it right here and twist it several times. That'll keep your coil from getting unwound. Very important step. Then, you need to remove the covering from the last 6 inches. Okay? It's not plastic, it's not going to come off in one piece. It's paint, enamel paint. So, you use your scissors and there's a technique. And this again is probably the hardest thing for people to get, is how to remove the covering off the end of the enameled wire. Open the scissors up. You're not going to use this surface. You're not going to use this surface. You're going to use that corner, that edge, right between the edges that actually cut, okay? Right in there. And if you do it right in near the hinge, it's usually sharper there. This is the technique. I'm going to wrap this around my hand once or twice so I have the last 6 inches or so, okay? Then I'm going to put the wire right there on that corner, okay? Not the flat part, the corner. I'm going to put my thumb on top of it and push with a moderate amount of force and drag it out to the end. And you should see the red paint come off and you should feel and hear it scrape. You don't have to press that hard. You just have to get the right angle. The right part of the scissors right in there and the right angle. Notice that I'm turning the wire as I'm doing this, going all the way around, removing that red covering from the outside. It has to be scraped off. A lot of people think they've got a better technique. There is no better technique using the scissors. You could sand it off with a bunch of sandpaper, but that is even more difficult for many people because the wire is so small. So, what I want to see you do is this. If you're struggling with that, call me over and I'll help you out. But don't do this. Don't put it on the table and try to go back and forth. As soon as you start doing that, you're going to screw it up. And if you press too hard, head up, Anthony. If you press too hard, you'll end up putting little nicks in the wire, and then when you go to wrap it around these screws, which is what you do at the end, it'll break right off, okay? Don't want that. So when we're done with the coil, hopefully the other 2 people at your station have gotten this ready. Head up, Zach. And all you do is you just wrap this last 6 inches around one screw, the last 6 inches at the other end around the other screw, and your coil then hangs off how much? 30 minus 6 is 24. 2 feet. It should hang down 2 feet. And that is what makes it difficult to use the fishing rod. Because when it's hanging down 2 feet, it kind of swings all over the place. When you're using the fishing rod, you cannot put your hands above the battery. The rules say, for our little contest, that your hands must stay below the battery. So you've got to operate it like so. Now, the fishing rod has to be prepared. It has to be hooked up properly. To start, all the wires are on one side. Take them off. Okay? Then you got to be able to read a schematic. We're going to work with schematics more in the upcoming weeks, but it's just a way of drawing a circuit. Instead of making a photograph, we use symbols. This is the symbol for a coil or electromagnet. You see it there. This is the symbol for a switch. You've got a push button switch. There it is up there. And this is the symbol for a battery. The diagram I've drawn there, the schematic I'm showing, shows you how to hook up this fishing rod so that it works properly. Each of those symbols is seen here on the pole. All you have to do is follow the path. So we start here, let's say on the battery, and we can see that there's a long line and a short line. The long line goes to what? The coil. So I simply take my little jumper, I hook it on the long line for the battery, and the other end goes to one of the coil connections. And then I follow that around. The other coil connection goes to switch. So I find the other coil connection and I attach it to the switch. And then from the switch it goes to the battery. So there's only one connection left to make. And you have a complete loop. When you hook that up properly, if you follow the directions, it should turn on this light bulb. The light bulb you just put on the end here as a test. Okay, while they're working on their coil, you can test it out. And that light bulb should come on only when you press the button. If it does, you've got it wired up right, you're done with your part. Okay? Once they're done with their coil, And you got it hanging down now 30 inches. You wind on that last 6 inches, and now you can try it out. Take the tape, put that out on the table. Take the washers, put them in a pile, and practice fishing. Give everyone a chance, okay? Make sure the hands stay below the battery. Try to pick up as many washers as you can and try to put them in like that small space would be a good practice. If you can do that, you'll do well in the contest tomorrow. If you can pick up more than 16, give me a holler. I want to see it, okay? Give everyone a chance to practice. What was that? Oh, you can do it, okay. All right, so to quickly review, your steps are the following. Oh, I should mention, at the end of the period, I need you to get this back the way it was. So that means all the wires should be on one end, like so. Everything should be back in your tray. And you'll take your coil with the 30 inches of wire like that and just wrap it around your hand, like so. Take the masking tape, wrap it around it a few times, and put your period and station number on it. And put it up there so it'll be ready to go for our contest tomorrow. So again, to quickly review, step 1, look at all the cores you've got. Sorry. Look at all the cores you've got and pick the one you think is best. Check and make sure it's not already magnetized. If it is, you'll have to pound on it with the hammer. Check and see that it will in fact stick to a magnet. Then straighten out your wire carefully. Make sure the end is free to spin and your partner smooths it out periodically. And you wrap it around, leaving about ½ an inch exposed on each end. Meanwhile, your other 2 teammates are getting this wired up, ready to go. Okay? When you're all done, you practice. At the end of the period, get everything back the way it was when you started. Put your name on your coil, and you're good to go. Easy, right?
Yeah.
All right, let's hammer.